In this video, we're going to learn how to name some special cases for substances. The first case of a special case is called naming molecular elements. Remember, these are not quite compounds, but there's still two or more elements connected together. So, example of a molecular element would be a diatomic molecule. The key word here, key prefix being di, which means two. So some molecules exist connected in pairs. For example, hydrogen exists as H2, oxygen is O2, fluorine is F2, bromine is Br2, I as I2, N as Cl as N2, and then Cl as Cl2. And the way to remember that these compounds exist in these diatomic forms, and I shouldn't have said compounds here, these substances exist in diatomic forms, is by using the trick Hofbrinkel. Hofbrincl, Hofbrinkel. And so these are your diatomic elements, your molecular elements. Remember, they're not compounds because it's two or more of the same nonmetal connected to each other. So diatomic molecules, a diatomic molecule contains two atoms specifically, and there are 1, 2, 3, 4, 5, 6, 7 of them. 7 elements that exist as diatomic molecules. Now, all of these elements that exist as diatomic molecules, most of them, are gases at room temperature. There are two exceptions, bromine and iodine. Bromine is a liquid at room temperature, and iodine is a solid, and you'll learn about why that is in future grades. It has to do with the type of forces that they have that keep them together. So to name these, you do have to follow a specific rule. If you have H2, you would have to write gas next to it because it's going to exist in that state, and that's called hydrogen gas. Oxygen would be O2 with little g next to it, and that would be called oxygen gas. Because if you just say oxygen, that might mean the atom. Fluorine gas, we know that's F2G. If we just said fluorine, that would just be F, fluorine. Now, bromine liquid, or liquid bromine you could say, when we say bromine liquid, would be Br2 little l here, liquid, in brackets. Iodine, on the other hand, you'd write it as I2 with a little s there. That means iodine solid. You don't change any endings. You simply state the name of the element and then its state, gas or liquid. And again, most of them are gases except for bromine and iodine. If you see nitrogen gas, you know that means the diatomic version. If I just said nitrogen, I probably mean the element on the periodic table, just N. Chlorine gas, that's the diatomic version. If I simply said chlorine, I likely mean on the periodic table. So you do have to remember these 7 diatomic molecules are going to be very important, especially when we go into chemical reactions. Remember that they're the Hofbrinkel elements. They're not compounds because they're two or more of they're two of the same element connected to each other. So that's one special case of naming. They don't really get a modification other than the fact that we tell you what state they're at room temperature, and that's their most stable state. Now, another special case is common names. Common names. So there are some substances that are so commonly used that instead of using the formula or the scientific name that you would use, that we learned about in class, we use more of their common name. So what I want you to do is try to pause the video and try to figure out what the formulas would be for compounds based on their scientific name, that we sometimes call the IUPAC, so the naming rules we learned in class is part of the IUPAC naming system, and also their more common name. So for example, if I said dihydrogen monoxide, you'd know from this that there's 2 hydrogens, 1 O, and from the common name, you know that's water as well, so H2O. Try to figure out the rest. So ammonia, if you don't know what that is, that's okay. From the common name, that's its common name, take a look at its IUPAC name. Nitrogen trihydride. So you would know that that's NH3. Ozone. like in the ozone layer. That's actually made up of oxygen. If you don't know its formula, take a look at the IUPAC name. Trioxygen. You know what tri means. That means 3. So O3. Methane. Methane is actually the gas that comes out of the gas lines when we light the Bunsen burners, and it's also a cow's fart. If you don't know the formula, take a look at the IUPAC name. Carbon tetrahydride. So we know there's one carbon because there's no prefix in the front. There's hydrogen in there, specifically tetra, that's 4. So this would be CH4. Hydrogen peroxide. Its scientific name is actually hydrogen peroxide because peroxide is actually a polyatomic ion, but it's also a common name because you can also call this dihydrogen dioxide. This is the more specific name because peroxides are a specific type of molecule. So just know that hydrogen peroxide, even though it looks like it's two nonmetals connected to each other, we don't typically call it dihydrogen dioxide, we call it hydrogen peroxide instead. So these are some common compounds that I do want you to know, not just their IUPAC name, but also their common name. We often will say water instead of dihydrogen monoxide. We'll say ammonia instead of nitrogen trihydride. We'll say ozone instead of trioxygen. We will say methane instead of carbon tetrahydride. I say common name. That's just a different name that we use, a different naming system. And then hydrogen peroxide, also a different naming system. We wouldn't use the molecular naming system. So do understand what these are. If I do ask you to name them, typically I'll ask you to name them using their more common name. So in this lesson, what we saw is there are 7 diatomic molecules, molecular elements, the Hofbrinkel elements. We saw that when you name them, you write them out using a symbol for their state, and most of them are gas except for bromine and iodine. We also saw that some substances go by more common names rather than the IUPAC name that we learned in class. There are other molecular elements that we didn't describe here in this note, but some worth noting for later. Sulfur often exists as a molecular element in the form of S8. That's its more standard state, still sulfur. It's usually solid. And then another molecular element that typically exists as a molecular element, or an element that exists in combination, is phosphorus. So phosphorus typically exists like this, as P4. So these are other notable ones to try to remember, and just be aware that they will show up in our chemical reactions. So you should be able to name these molecular elements and common elements, or common compounds.